Make sure I'm recording. Yes, it is. Good. All right. So what do we have right here? It's equation of a line. So we got one form of an equation of a line. We're going to learn several forms of an equation of a line. We're going to do the most basic one first. Okay. So before we do that, before we actually get to, well, the first one is kind of an equation of a line. I just kind of didn't get to it. Meant to do this yesterday yesterday. So let's go to example 4. So let's go straight to this example. And it tells you to graph x equals 3. Now look at that. It doesn't have an x and a y in it. Like on the quiz you just took, didn't it have an x and a y in it? Yeah, but this one only has an x in it, okay? This is actually pretty easy. This is a pretty simple thing to graph. If I wanted to graph, let's put a little graph here. So right here, x and y axis, okay? And we wanted to graph this. Now, normally, what would we do to graph so far? So far, we learned how to do this little box, right? This little T, whatever you want to call it. And you put an X and a Y, right? You pick some values for X, and then you figure out what Y is going to be. What's the problem, though, on this? There's no Y, okay? So guess what X is going to be? What is it? 3. That's right. No matter what the Y is, it doesn't matter what the Y is. The X is always going to be what? 3. So I could put any values of Y in here. I could put a 0 here. I could put a negative in here. I could put a positive in here. It doesn't matter. Okay, what the Y is, the X is always going to be what? 3. So you're going to come over here on the X-axis, and you're going to put a dot right at 3. Everybody's watching? Okay. You're going to put a little dot right at 3 on the X-axis. Remember, that's the X-axis. This is the Y-axis. And the Y's could be anything at all. All right? There's 3, 0 right there. You could put a 3, -1, which would be right there. You could put a 3, 5, which would be way up here. You see what I'm doing? What kind of a line is it making? No matter what numbers I put in for Y, X is always going to be 3. So what kind of line is it going to look like? Say it. A vertical line. Okay, it's going to be a vertical line. Very good. So let's just draw a nice little line. We'll start here. Just go through like this. And let's put a little arrow on it just to show it's a line. So that right there is the graph of x equals 3. So if I ask you to graph x equals 3, you're not just going to put a dot at 3 on the x-axis. You're going to actually draw a line through it, and it goes through the x-axis. Everybody see that? What's the x-intercept? If I ask you the x-intercept, what would the x-intercept be of this line? It's where it crosses the x-axis. Remember, it's an ordered pair. Made a big deal about that on the quiz, all right? Even though people didn't listen to me the first time. Trying to help you out, right? So I doubled up, and I helped you even more. So what's the x-intercept? It's an ordered pair. So where does it cross the x-axis? At what? 3, 0. So that would be the x-intercept. What's the y-intercept of this line? This red line right here. What's the y-intercept? Where does it cross the y-axis? Doesn't, does it? Doesn't cross it'll never cross the y-axis. It goes parallel. We're going to talk about that probably in the next lesson. It's parallel to the y-axis, but it'll never cross the y-axis. So there is no y-intercept. So if I ask you for the x and y-intercept of a line like this, you would just say that there is no y-intercept. Got it? And the x-intercept would be 3, 0. All right. So they give a little, what do they call it? They call it a theorem. It's not much of a theorem, but they do call it a theorem. Yes. Oh, man, I thought you were going to have a great question for me. You got to go think about it. All right. Here's a theorem. It's just a rule. It's just a math rule. It's a fancy name. Okay. It's called theorem. It says a vertical line. I'm not going to write down every word of this. It's in the book. Okay. So a vertical line is given by the equation x equals a. Now the a could represent basically any number. All right. So they just put an a in, like right here. What was the a on this equation I gave on example 4? Anybody here today? Killing me, man. It's right here. It's 3. All right. So x equals 3. So the a is 3. So that's what the theorem says. So when you have a vertical line, the equation of that line is x equals a. So that's our first equation of a line. Remember our little title right here, equation of a line? That's our first equation of a line. It's not our first. We've actually done some, and we've graphed stuff, right? Put that little t thing there. We've graphed them. We've seen an equation of a line. Matt, can you get that, please? All right. So what we're going to do now, that kind of leads us up a little bit to this thing that we're going to do right now. This is like your first kind of official form of an equation of a line, and it's called the point-slope form. If you've taken, I'm sure you hate me saying this all the time, but I always have to refer to it. It at least gives you a frame of reference, right? You probably learned this in Algebra 1, definitely in Algebra 2. It's called the point-slope form of an equation of a line, okay? So it's an equation of a line, but it's a certain type of form. It's called the point-slope form, and it should make sense. They didn't just pick this name out of the blue, because if you are given a point, what's a point look like? It's a what? I said it a couple times, especially during the quiz. What is it? What do we call something that looks like this? Say it, Haley. It's an ordered pair, okay? So if they give you a point, an ordered pair, and if they give you a slope, what letter did we use for slope? M. Remember that yesterday? All right, so if they give you a point, they give you a slope, you should be able to put it into the point-slope form. In fact, a little bit later in this lesson, it'll be today, they're actually going to give you 2 points, and they're going to ask you to put it into the point-slope form. You're like, well, how can I do that when they don't give me a point, or they don't give me a slope? Well, how could I do that? If I have 2 points, can you find the slope if I give you 2 points? Sure you can, because we did that yesterday, right? It's rise over run, change in y over change in x, y2 minus y1 over x2 minus x1, any of those things. So if they give you 2 points, you should be able to find the slope. We are going to do an example like that today. All right, so just hang on. All right, so let's talk about the slope, because we're going to come up with the point-slope form. I could just sit here and just say, all right, here's the point-slope form. This is how you use it. Boom, go on. But I don't like doing that. I like to show you where it comes from. All right, so it comes from the definition of a slope. Do you remember the definition of a slope? y2 minus y1 over x2 minus x1. But this time, they're going to just put y minus y1 over x minus x1. When you have this little subscript right here, that little 1, that means it stands for a certain point. All right, this y is just going to be the letter y in our equation. You're going to see our equation is just going to be the letter y. This x is just going to be the letter x. But this y1 and this x1 is going to stand for a point that's on my line. All right, so that's what that means right there. Of course, the m is the slope. Now watch, it's pretty simple. What they're going to do, the point-slope form, they're going to get this by itself. Are you watching? Writing the stuff down? Okay. So they're going to get this by itself. So that means I have to get rid of this x minus x1. How am I, algebraically, how am I going to get rid, Mac, how am I going to get rid of the x minus x1? It's being divided. So, what? Say it. Oh, you I saw your mouth moving. What's the opposite of division? Okay, so how do we get rid of stuff in algebra? We always do the opposite, right? So if it's being divided, what are we going to do? Say it. There you go. Okay, you're going to multiply by this x minus x1, okay? So what's that going to look like over here? It's going to be m times x minus x1 equals what? Y minus y1. Everybody see that? Basically, I did this. I multiplied by x minus x1 over here, and over here, I multiplied by an x minus x1. Do you see what happens? That cancels right there. I got this. I just moved it around. This isn't very pretty. They don't usually write it like this. They usually put the y's first. Okay, so if we put the y's first, here we go. For the big reveal, this is the point-slope form. This is something that you're going to use and you need to memorize. If you can't memorize it, go back to the definition of the slope. All right, and you can figure it out. And that's how we figured it out. So there's my point-slope form formula. Everybody got it? So that's how we get it, all right? You're not going to really have to do that on homework or anything. You're just going to have to be able to use it. So guess what they give you right now? They give you an example, okay? And it's example 5. And what they do is they give you a point, and they give you a slope, and you just need to put it into this form right here, all right? So let's do that. They give you the point, or first, they give you the slope. Doesn't matter what order. They give you a slope of 4, and they give you a point of 1, 2. Okay? Now, with that information right there, I could just graph that pretty easy. I could put 1, 2 on my graph, and then count up 4 over 1 for my slope. I could graph it just with that information. But there's a lot of times we want to write it as an equation of a line. Okay? Girls, you up here? All right. So what we want to do is put it in here. Remember, the y just stays a y. The x just stays an x. Remember what I said that the little subscript meant? It stood for the point that they give you. All right? So here's a point. So this is not just an x and a y. It's a what? It's an x1 and a y1. And now it's just plug and chug. All right? We really don't have to do any math. Well, we will in a little bit. Okay? But just to put it in this form, you don't really have to do any math. So here's how we do it. You're just going to put y minus y1. What's my y1 in that information that they gave us? It's 2. So you put a 2 right there, equals the m. What's the m, or the slope they give me? It's a 4. Everybody got that? Just plugging and chugging, right? Just taking the numbers they give me, put it into my little formula, and just see what I get. So I put a parentheses. Remember, that x just stays an x. Okay? Remember I said that earlier? That's coming to fruition right now. Okay? Minus x1. What's my x1? It's the x part of that point they give me. There you go. So I could just circle that. And if they ask you to put it in point-slope form, let me write it here since it's off the page. Point-slope form. Because sometimes they will. Sometimes they're going to ask you to write your equation in point-slope form. Sometimes they're going to ask you to write your equation in whatever other form we're going to learn. We'll learn that tomorrow, okay? But right now, this is the one we know. And if they ask you to put it like that, that's it. Pretty easy, isn't it? Sure it is. Sometimes they want you to get y by itself. This kind of points to what we're going to do tomorrow, all right? I'll show you a little bit. What if we wanted to get y by itself? Okay, and simplify this and just get y equals blank, right? And you've seen this before. I'm not giving anything away that's new, right? What is the equation that y equals mx plus b? You remember that, right? You've done that for several years now in your math classes. So that's what we're going to do right here, okay? So I want to get y by itself. So first thing I'm going to do, I'm not going to get rid of that 2 just yet. What do you think I have to do to get y by itself? Over here on the right. What would you do with that 4? Distribute it. Very good. Okay, so we distribute it. So it's 4x minus what? 4, right? And now we do one more step. Let's push this up a little bit so you can see. One more step. I'm going to add a 2. I'm going to add a 2. So what do we get? Y equals 4x, what? Minus 2. This equation right here and this equation represent the exact same graph, all right? I'm not going to talk about what the negative 2 is. You probably know already. We know what the 4 is. The 4 is the slope, right? Because that's what they give you. But those are 2 important equations. Sometimes it's easier to use this equation, or formula, I should say, and sometimes it's easier to use this little formula, or this little equation right there. But in the book, they did get y by itself, so I figured let's just get y by itself, because you're going to have to do that eventually. All right, so that's basically all there is to that. I think we go right to example 6. Yes, we do. All right, what was that first example that we did? We found the equation of a, what kind of a line? Thank you. A vertical line. Okay, and what was that equation? It was x equals whatever number, right? We just put a in to represent whatever number, okay? So guess what kind of line we're going to do now? we're going to do a horizontal line, okay? So horizontal line. Just take a wild guess. If a vertical line is x equals something, what do you think a horizontal line is? It's probably going to, that's supposed to be a z. It's a like z, like it's like a hybrid cursive print z. All right. Usually I do a z like that. I put a little thing through it like that. I don't know. I started that a bunch of years ago. Anyway, that's horizontal. So what do you think it's going to be? It's going to be what? Y equals whatever number or letter. They use B instead of A just so you don't get confused. Okay, it just stands for any number. So let's see. Let's see how we get this. Okay, I kind of ruined the surprise for you, but this is how we get this. So example 6. This is what we're eventually going to get right here. All right. It says find the equation of a horizontal line. So it's, I'll write that down. So find the equation of a horizontal line. Now they tell you it's horizontal, okay? I'll put a little z like that. Is that better, Renee? You like that better? Okay, good. Of a horizontal line that contains the point, I'm not going to write all that, but contains the point 3, 2, and they tell you a slope. The slope is 0. So when they give you a point and they give you a slope, what do you think the best formula for an equation of a line is going to be? We just talked about it. What? A point-slope form. Very good. Okay. Seeing if you're awake. All right. So we're going to use the point-slope form. I would write it down a few times so you remember it. Okay, because you're going to have to remember it. You're going to have to memorize it. What is it? Point-slope form. It's y minus what? y1 equals m parentheses x minus x1. Remember, the x1 and the y1 represent the point that they give you. Do they give us a point? Sure they do. It's 3, 2. So there's my x1, and there's my y1, and there's my slope. All right, we're doing this for a reason. Remember, the x and the y just stay x and y. Okay, the other three things, the x1, y1, and the m, they're numbers. We're going to put in numbers for those, and we have those numbers up here. So the y just stays a y minus y1. What's my y1? It's just a 2, so it's y minus 2 equals slope. What's my slope? 0. By the way, did they tell you the slope was 0? I think you had to figure out the slope was 0. We did this yesterday. Remember horizontal line? Remember we went skiing and it's horizontal, it's completely flat. How fast are you going to go? You're going to go 0 miles per hour, right? So that's the slope is 0. So I think you had to figure that out. In my notes, I just put m equals 0, but I don't think they gave that to you in the example in the book. But they did tell you it was a horizontal line, so we know the slope is 0. So that's important. All right, so we put a 0 there, and then x minus. What's x1? It's 3. Can somebody get the door, please? Let Justin in. All right, let's see what we get. So I got y minus 2 equals, let's distribute the 0. In fact, do we really have to distribute it? It's 0 times anything. What's 0 times anything? It's 0, so let's just put a 0 right there. And let's get y by itself. Okay, we don't like it like this. Okay, it looks kind of ugly. Let's get y by itself, and what is it? Y equals what? 2. That's the equation of the line. And check it out. It's a horizontal line, so you don't have any x's in it. It's only y equals whatever. Isn't that what we said it was going to be? We just kind of guessed, right? That it was going to be y equals a number because a vertical line was x equals something. So we figure a horizontal line is going to be y equals something. And sure enough, we just saw right here when you have a horizontal line, you stick it in that point slope form, sure enough, that's what you get. Okay? If we graphed it, let's do it super quick because I got one more example to do before the bell rings. If we graph it, remember if we do that little XY chart thing, what's y going to be? It's going to be 2 every single time, isn't it? It doesn't matter what your x is. Your x could be a negative, it could be a 0, it could be a positive. It doesn't matter because the y is always going to be what? 2. Let's do that in a different color. Okay, it's going to be right there. And it doesn't matter what the x is. You're always going to go up 2. So let's see. About right there is good. Right there. And there we go. So that's how you would graph it. That's how you would graph y equals 2. We got it? Pretty easy, I think. If you just remember, x equals is a vertical graph. Y equals, it's a horizontal graph, right? Because it goes through those axes. When it's x equals a number, it goes through the x-axis. So it's got to go up and down, right? If it's y equals something, it's horizontal. It goes through the y-axis, and so it's flat. It's horizontal. All right. Here's something that they could give you. I mentioned this earlier, and now we're going to get to it. Example 7. I don't have much time, but we'll get at least started on it. I'm not going to write all this out. It says find the equation of a line. All right, that's what we're trying to find. And what is an equation of a line so far? It's this. That's the only form that we technically know right now. Okay, so we want to find this given 2 points. So they give you the point 2, 3, and they give you the point negative 4, 5. And you need to put it into this form right here. What are you missing? This time they give you 2 points. Before, they always gave us 1 point and a slope. But this time they only give you 2 points and they don't give you the slope. But, remember we talked about this a few minutes ago? What can you find given 2 points? You can find the what? Find the slope. So let's find the slope. Remember what it is? Subtract the y's, subtract the x's. All right, subtract the y's. It doesn't matter what order you subtract them in. I'm just going to do the first one minus the second one. Subtract the x's in the same order. Now, it does matter what order you do them. You just got to make sure you subtract them in the same order. So what does that give us? That gives us negative 2 over what? 6, right? And reduce it. Always reduce it. It's negative 1/3. So that's my slope. My slope is negative 1/3. Now what we can do is now we can find the equation of a line. Watch how easy it is. This time they give you 2 points. It doesn't matter which one you use for the x and the y. Which one would you rather use? 2, 3 or negative 4, 5? 2, 3, right? Because it's all positive. It's an easier one. That's what I would use. So I would use this and I would use this. It's not my answer. It's not why I'm circling it. Okay, I want to put it in this formula. So it's y minus y1. What's my y1? It's 3 if I choose this point. Okay, equals m, which is negative 1/3, and then x minus the x1, which is 2. So if they ask you to write an equation of a line in point-slope form, that would be acceptable. But guess what? You don't just have to use this point. You could also what? Use the other point. And it looks like your answer is completely different, but it's really the same exact line. So let's do that. Let's use the other point. So it's y minus y1, which is 5, equals, the slope is the same, and then x minus what? Negative 4. What's minus a negative 4? It's a plus 4, isn't it? So you actually, if they ask you to write it in point-slope form, you actually have 2 possibilities for an answer, but they represent the same exact line. We good with that? You could graph it really easy. I'm going to do this super quick. I'll just keep everything blue so I don't have to take time to change colors. Okay, so you could graph it several different ways. I would just take one of these points, 2, 3. So watch, 2, 3, 1, 2, 3. Put a dot right there. And I could, if I wanted to, just put negative 4, 5. 1, 2, 3, 4, and then go up 5 right there. Connect them like this. Extend it out. I always like to extend it out a little bit. Put some arrows on it. And there you go. And there's your graph. That's it. Okay, your homework. I know you already have the lesson plan thingy, but I always like to write it on here. It's section 2-3. It's part 2. And it's page 186. And it's 45 to 58. Now, it's 58, so guess what? Yeah, you're doing all of them. Okay? So there's your homework. All right, I'll shut this thing down. I want your homework before you leave, okay? So bell's about to ring, so turn your homework in.